So hopefully you've been playing around with this function, f of n equals n squared plus n, choosing different input values, and like in the Canvas page, it says, what if n was 1? Well, 1 squared, 1 plus 1, 2. F of 1 would equal 2. And what are at least two factors of 2? Well, 1 times 2. But I want you to see a few more. So what about f of 3? F of 3. So if n is 3, 3 squared, 9, plus 3, 12. What are at least two factors of 12? And I'm strategically choosing two of the factors here to try to make a point. But the factors of 12 are the 3 plus times 4. 3 and 4 are factors of 12. Interesting. What if we go on to f of 4? What if I let n be 4? N squared, 4 squared, plus n plus 4. Remember, n is 4. 4 squared is 16. 16 plus 4 is 20. So 20, what are some factors of 20? And again, I'm being very strategic here. I'm choosing the two I want you to think about. The two I want you to think about are 4 and 5. So 4 and 5. Remember before, it was, oops, going the wrong way. Before, when I had a 3, the factors that I had you choose to look at were 3 and 4. 3 times 4 gave you 12. And now 4 times 5 gives us the 20. Do you see what's going on here? What if we try f of 6? What if n is 6? N squared, 6 squared is 36, plus n, which is 6. 36 plus 6 is 42. What are some factors of 42? Now, specifically, what are the two factors I want you to be thinking about right now? Well, two factors of 42 that are of interest to us here would be the 6 and the 7. 6 times 7 is 42. Oh, let's see if you see what I'm seeing. So when I plugged in a 3 for n, when n was 3, we got an output of 12, and factors of 12 were 3 and 4. When I let n be 4, we outputted a 20, and factors of 20 were 4 and a 5. And when I did a 6, we outputted a 42, and it just so happens that some two factors of 42 would be the 6 and a 7. 3 and 4, 4 and 5, 6 and 7. Do you see a pattern here? Now, what if we went crazy like I showed you in the previous video? We don't have to just deal with whole number factors in the algebraic world. So what if I let n be, and I'm just being crazy here, y'all. What if I let n be 8.12345? Well, if you input an n value of 8.12345 and you square it, because it's n squared, and then if you add n, 8.12345, when you compute that, try it if you like, on your calculator, you get 74.11388899. Now, do you think you could come up with two factors of 74.11388899? Now, I encourage you, pause the video right now. I'm going to pause a little bit here. I'm going to dance around a little bit to make your brain think. But if you back up and look at what's going on here, when we plugged in a 3, when n was 3, two factors were 3 and 4. 4, two factors of 20, 4 and 5. Two factors of 42, 6 and 7. So what do you think? Oh, what do you think two factors of 74.11388899 would be? How about the n that I started with and one more? Did you see that pattern? The n that I started with, 8.12345, plus one more would be 9.12345. If you multiply those two numbers together, you will get 74.11388899. At least round it off a little bit here because we're doing some rounding. Take a look. I just threw it into the Google calculator. So if I multiply that original n times one more than n, like you saw, we do indeed get 74.11388899 and some more because we're doing some rounding here. So what's going on here? What do you think I'm trying to get you to see in general about factors, two factors of the expression n squared plus n, the quadratic expression n squared plus n?